Maayong buntag, ma'am. I am Angelo Di Climaco and my co-groupmates are Panhay, Verano, and Likit. So allow me to present to you our tagging, which is the seed maturation curve of mung bean on different harvest dates. So as we all know, mung bean is one of the most important legume crops in South and Southeast Asia. It is a warm season annual plant that is highly branched and has trifoliate leaves like other legumes. The plant is upright and vine types of growth habit occur in it, with plants varying from 1 to 5 feet in length. The pale yellow flowers are borne in clusters of 12 to 15 near the top of the plant. Mature pods are variable in color, about 5 inches long and contain 10 to 15 seeds. The importance of studying the seed maturation curve of mung bean lies in the fact that it provides valuable information about the physiological changes that occur during seed development. This information can be used to optimize the timing of seed harvest and storage, which can have a significant impact on seed quality and yield. Therefore, an understanding of seed maturation and development is becoming increasingly important in seed operation. It is now well established that the period between physiological maturity and harvest maturity is critical in terms of seed quality. The climatic conditions that prevail during this period often establish and or condition the quality of the seed. So our objective is to determine the moisture content, seed size, and dry matter of the crop assigned, determine the germination and germination capacity of the test crop, and determine the physiological and harvest maturity of the assigned crop, and establish the seed maturation curve of the assigned crop.
Good day everyone, my name is Charito Lekit Jr. I will discuss the materials and methods of recalcitrant. The materials and equipment that has been used is this experiment are the following: mung bean seeds, tissue paper, microwavable plastic container, and smartphone for documentation. Procedure: we decided of what are the crops being used, and flower mung bean is our assigned crop. We sure that we have enough number of plants planted to complete the exercise. At the start of flowering stage, we start tagging the flower. The date when the flower first occurred must be recorded in the tag. 1 week after pollination, we harvest 5 to 7 pods containing at least 10 seeds. Air dry harvested pods and germinate the seeds once dry. Account for the percent germination, seed vigor, and number of ungerminated seeds. Be sure that quantify the ungerminated seeds as fresh seeds, hard seeds, and deteriorated seeds. Be sure that root and shoot length of winging scale is available. We harvest and germinate every 2 weeks to determine the right physiological maturity of the chosen crop. We document all activities conducted.
I'm Jerry Panay. I am going to discuss about the results and discussions of mung bean, the percent germination, and the stalk flowering. As you can see in the figure 1, the percent germination of mung bean seed from days to flowering, 7 days, 14 to 21 to 28, and the termination day. Bignara radiata seed display a very low or no germination at all constant temperature and storage. Perfect germination has observed only in 41 and 21 days to flowering, as you can see in the figure 1. Then, however, in first collection of sample, which is the 7th day, it has 70% germination 3 weeks after sowing. In second collection, which is in the 14th day after week, 100% germination has been observed, but it has an abnormal seedlings. In termination period, which 1 week after the last collection, low to no germination has been recorded, as you can see in the figure 1. This means that the germination percentage of the mung bean are low, most likely reason for seeds not germinating. With too little or no water, seeds remain dormant. With too much water, seeds become susceptible to rot or infection from soil-borne fungi, also referred as dampening off. 30% abnormal seedling of mung bean, Vigna radiata. You can see from 7 days to flowering, 30% of seeds are abnormal seedlings in figure 1, but in decrease in D14 and 21, which the seedling are emerged in good condition. However, in 28 and 35 days, the abnormal seedlings are increased to 60%. 21 days, 100% abnormal seedling in 35 days. This means that above data shows increasing abnormal seedling as days to collection. Thus, it is extremely rare that a seed line will be dominated by the presence of dead seed, but it is not uncommon that a seed line will be greatly influenced by the presence of abnormal seedlings. If the abnormal seedlings count exceeds in 15%, it results in the germination percentage dropping below 85%, and this can have marketing complications.
For the figure 3, the percent decayed seeds of mung bean, the data above shows that in the first collection, the decayed seeds is 10%, same with the 28 days, and 0% for second and third collection, or the 14 and 21 days. The decayed seeds increases as approaches to the termination stage, which is shown above, in the days to termination to 35 days to flowering. The percentage decayed seeds is 40%. This means that the decayed seeds are those seeds that are not able to germinate but have imbibed water and produced leaches and became decayed. For the figure 4, speed of germination index of mung bean, the germination index of 7 to 14 days is increasing with a value of 0.26 and a 1.71 respectively. From 21 to termination days, the germination index decreases with a value of 1.71, 0.68, and 0 respectively. Moreover, delay of seed harvest of a crop increases seed losses due to shattering or the seed drop from pods. However, early harvest reduces seed germination and increases seed dormancy, according to Moulin et al. And for the figure 5, the seed maturation curve, according to Kumar et al. 2012, the minimum yield moisture content of mung bean is 12%. Based on the research findings of Worku and Licker-Merriam on 2013, that the highest total dry matter was produced from first sowing date, while the rest of the sowing dates did not show statistically significant differences. First sown mung bean produced 33, 38, and 45% larger final to total dry matter compared to second, third, and fourth sowing dates, respectively.
So again, I am Angelo Di Climaco, and I am going to talk about the table 1, which is the seedling vigor index of mung bean. So in 7 days after flowering, nagkwantag shoot length is, yung shoot length is 8.47, yung root length is 1.95, then the percent of seed vigor index is 6.46, as well as the 14 days after flowering, yung nagkwantag shoot length is 11.77, yung root length is 6.54, yung percent sa seedling vigor index is 11.35. Ang 21 days after flowering, nagkwantag 7.07, ang root length niya is 4.2. Dayon percent cervix index vigor index is 9.2. 36. While the 28 days after flowering, yung shoot length is 5.49. Yung root length is 2.63. Yung percent sa seedling vigor index is 5.03. So, the seedling vigor index of mung bean are decreasing from 7, 14, 21, 28, and 35 days after flowering with a value of 6.46, 11.35, 9.36, and 5.0 respectively. So in conclusion, in seed operation, knowing seed maturation and growth is becoming increasingly crucial. The time between physiological development and harvest maturity is now well known as essential in terms of seed quality. Based on the experiment at all consistent temperature and storage times, Vigna seeds exhibited very poor or no germination. When the seed was immature, it was sowed and imbibed water and germinated after 3 days. However, certain bacterial microorganisms grow in the medium and form some seed to molds. Moisture content must decrease and vitality must increase as the seed grows. However, the viability of the seed is reduced throughout this activity. The cause of mung bean seeds declining vigor and germination is due to a variety of abiotic and biotic factors, which may indicate if the seed's viability is good for planting material. Indeed, this activity was a wonderful aid for the students to categorize and identify how the seeds respond if they are harvested in an immature state, and by doing so, each seed has its own period that they need to be harvested and to have a good germination and viability. So these are all our documentation. First is the tagging data, which is November 15 to December 10. In figure 6, you can see the first collection of mung bean samples 7 days after flowering. And then figure 7, the second week of mung bean sample collection, which is the 14 days after flowering. And figure 9, third week of mung bean sample collection 21 days after flowering. In figure 8, fourth week of mung bean collection 28 days after flowering. And the figure 10, the shoot and root length of 7 days after flowering at 35 days. In figure 11, you can see the deteriorated seeds of 35 days after flowering collection of mung bean. In figure 12, you can see the shoot and root length of mung bean, which is the 28 days after flowering at 35 days. And then the figure 13, you can see the shoot and root length of 14 days after flowering at 35 days. And the last is the figure 14, which is the shoot and root length of mung bean at 35 days of 28 days after flowering. Thank you and advance Merry Christmas.